All right, so we are going to pick up now and going into the specific structures and functions of the brain. So the brainstem is, or the brain is kind of divided into three categories: the brainstem and the cerebellum, the limbic system, and the cortex, or the outer covering. So today, the first part we're going to talk about is just the brainstem and the cerebellum. Then in the next video, we'll talk about the limbic system, and then in the next, we'll talk about the cortex, or the cerebral cortex as it's sometimes referred to as. So the brain stem is at the base of the brain. So if we look at our picture over here, you can see this is the neck, and it comes up. It's the spinal cord swells into the brain stem. And the brain stem kind of is in the very, very middle of your brain. So when we saw all those pictures of people with nails and things in their brain, you know, most of them did not reach that inner core, which is one of the reasons why they were able to survive those injuries. Because the brain stem is really where the survival things is, the survival structures are. My grammar is great here. So one of the most important is the medulla. So the medulla is at the bottom of the brainstem. You can see the brainstem comes in here, swells into the medulla, and it controls the most basic functions such as heartbeat and breathing. Now, some of you may know who Christopher Reeves is. He was the original Superman, and he was this like action hero guy, and he fell off his horse, and he actually broke his severed his spinal cord right at the medulla, just enough that he didn't die, but he could not breathe on his own. He needed breathing aids and respiratory aids. So it's kind of a very subtle, slight thing, and he was very lucky, because if it would have been just a little higher, it would have gotten the heartbeat part, which obviously we can't live without a heartbeat. So the medulla controls breathing and heartbeat. Then, kind of the flip side of that, if someone has total brain damage above the medulla, meaning that they damaged everything above it, they're still going to breathe independently, right? So they could still breathe even though they're technically brain dead. Now the pons sits next on top of the medulla, and the pons helps to coordinate autonomic or automatic and unconscious movements. And it's also regulated with sleep. So there's a little thing in here called the optic chiasm in the pons that releases melatonin, which helps us regulate sleep as well. Then on the tippy top, right, of the brainstem is the thalamus. Now, we've talked about the thalamus before, right, when we talked about our senses. Every sense except for smell is routed through the thalamus. Remember, the eyes comes in, optic nerve, thalamus, visual cortex. The auditory stuff, it goes auditory, you know, the ears, thalamus, auditory cortexes. So everything goes through the thalamus. It's kind of the sensory switchboard or the router. Remember, except for smell. Everything except for smell, very important here. And the thalamus also sends messages from the cortex to the medulla and the cerebellum. So it kind of works both ways. So messages can come up from the spinal cord to, up from the spinal cord to the thalamus. They can go from the other areas of the brain into the thalamus and then back around. So it really does route any kind of sensory information to wherever it needs to go in the brain, except for smell. So if somebody were to damage their thalamus, like, one of our people with their nails, right? If it would have gotten in and hit the thalamus, well, maybe it damaged kind of the visual pathway, so they would technically be blind, because even though their eyes worked fine and even though their visual cortex worked fine, if the visual part of their thalamus got damaged, then they would lose their sight. Same with ears, same with smell. Same with touch, everything except for smell. They would obviously still be able to smell if the thalamus was damaged, because smell does not go through the thalamus. All right, and then kind of in between these things, kind of in this, here's the thalamus, here's the medulla, kind of a thing, there's the reticular formation. And the reticular formation is kind of a network, a nerve network in the brainstem. And it enables alertness, and arousal from a coma to wide awake. And how do we know this? Well, we do experiments with cats, and what they found is that if you were to stimulate the reticular formation of a sleeping cat, it would bound awake, wide awake. Now, on the flip side of that, if you were to sever their reticular formation, they would fall into a coma. Okay, so the reticular formation has to do with our alertness, and if it's damaged, then we lapse into a coma, which a coma is technically a state of complete an arousal. It also helps to filter incoming sensory information. So it does, that's when we kind of talk about like this net, it does kind of help to filter and drive things up into the thalamus. Now, the cerebellum, which we've talked about before when we talked about memory, and remember we talked about the cerebellum helps to process those implicit memories, right, the automatic kind of memories. So it also helps to coordinate voluntary movements such as playing a sport. Now, an important thing to remember with the cerebellum does not start movements. It's not the part of the brain that says move your hand, move your leg. Okay, it coordinates it. It helps you act balanced. Okay, it helps you walk smoothly. It helps you not walk around and trip all over yourself. Okay, now we know through further research that the cerebellum also helps with other things such as enabling nonverbal learning and memory. So remember when we talked about those implicit type memories, those procedural memories, we know that those as well are kind of processed through our cerebellum. So now if we look at where our cerebellum hits, here we have our spinal cord, right, which swells up into our brainstem. The cerebellum kind of sits on the back bottom part of your brain, and if you notice, the tissue of the cerebellum is a different type of tissue than the rest of the brain tissue. All right, so we're going to stop there. Next time we're going to pick up on the limbic system.